Hi guys and welcome back to my channel. In today's video I would like to show you my fully upgraded Haiboxing 18859 RC car. In my previous two videos I showed the conversion of the shock absorbers and my first low budget brushless conversion. Since then some exciting upgrades have been made to this car, which I would like to present you here today. And at the end of the video we go for a short test run and speed test together. So let's get started and take a look directly under the body shell. My first tip is to stick some foam washers to the mounting points of the body shell, so it sits nice and tight and will not rattle. You already saw in the intro that I have another orange and a blue body shell. Yeah, and this orange one has seen a lot of crashes in the past. This blue one is still brand new and will be a replacement part for the future. You can see immediately that a lot of parts and cables are added under the body compared to the stock version. Originally this car was the brushed version of the 18859, which is the cheapest version of this model. Currently this Hobbywing combo is installed. The ESC is the 16BL30 and the motor is the 2435 brushless motor that delivers 4500 kV. In the past I tried two other motors, on the one hand the Surpass 2435 brushless motor 4800 kV and this original 3300 kV Haiboxing motor. But I think this matching quick one combination of motor and ESC performs a lot better in terms of torque and maximum speed. Both motors are used with this 18-tooth pinion, but especially the 4800 kV motor turns a little bit hot, which means that there is too much load on this high kV motor, and so I bought this 16-tooth pinion to make the gear ratio a little bit shorter. I'm very impressed how the car drives now with the combination of engine, gear ratio and tire size. It has a good torque, top speed, and the ESC or engine doesn't get too hot. Here you can see the manufacturer and part number of the 16-tooth pinion, but I will put here everything in a video description. Maybe a small hint. I also tried to use this 16-tooth LOSI pinion. According to the datasheet it has a 2mm shaft diameter, but when I measured it I saw it has a 2.3mm shaft and so I cannot use it. I don't know what's wrong here. The nice thing about this Hobbywing combination is that the ESC is programmable. I just bought this program card for the ESC and so you can adjust different parameters. Just unplug the receiver and connect the programming card instead. If you now switch on the power supply you can see all the parameters that can be set. These parameters are like running mode, the brake force, the punch, so the acceleration of the car, the cutoff voltage and some safety features like the overheat protection and a lot more. If you're interested in my configuration then just drop me a comment and I will go into this. Due to the fact that the receiver and ESC are no longer combined in one part, which was the case on the original Haiboxing car, I needed a new receiver and of course a new remote. After some research I decided for a RadioLink remote and receiver. Here you can see the receiver. It's the R7FG with 7 channels. This receiver has an integrated gyro and is able to provide telemetry data to the remote. Here's the RC4GS remote. It has a nice display for all the adjustments that can be made. But today I don't want to go very deep into the configuration of the remote. But if you're interested, I can do another video for this. Let me quickly show you the gyro function of the receiver. In general, the gyro is able to detect if the car spins out, for example on a loose track. In this case, the receiver will perform a very quick automatic countersteer. The angle of the countersteering is linked to the channel 3 of the receiver. Let me show you the maximum countersteer. If I set it all down to 0, then the gyro is completely disabled. Usually I set the value around -30, which is a good compromise for all types of tracks. To summarize, I would say that the gyro can support your driving quite well. Let's come to the battery. Currently I have installed this original LiPo. It is a 2S 7.4 volts with 850 milliamps. And I think the discharge rate would be around 20 C. But after around 1 year of use this battery is worn out and needs to be replaced. Currently I use this Red Power LiPos with 1100 milliamps and 7.4 volts, so 2S as well. And you see that I changed all the connectors in my car to the XT60. I had briefly tried out this 11.1 3S LiPo, but I would strongly not recommend to use this. With this LiPo, the car is way overpowered and you are going to destroy the car. If you turn on the power, you can hear what type of LiPo is recognized. These two short beeps indicate a 2S LiPo. And if the ESC beeps 3 times, then we have a 3S LiPo. Out of the box, this car comes with 2 bright front LEDs, but the rear bumper has also mounting points where you can install some LEDs. And that's exactly what I did, including a new wiring. You just have to consider that the new ESC is running on 6 volts instead of 5 volts. So all the resistors have to be recalculated and replaced. That's the prototype for the power distribution. I will build this a little bit smaller in the future. The lighting doesn't look just cooler now. It also helps to recognize the orientation of the car from greater distances. I think that was all the details about the engine and the electronics. I would now like to continue with the suspension and the wheels. Here I have also tried out a few things to make the car handle really well. Good handling is at least important to me as power and top speed. I've mounted these Proline Badlands tires that are especially designed for 1/18 scale vehicles. Actually they are sold for the Arrma granite chrome, but due to the 12mm hexes you can fit them on this Haiboxing car. I just can recommend these tires because they have a lot more grip than the original ones, and that is really needed to control the power of this car. As you can see here, the Proline wheels have a few millimeters more in diameter and therefore they give a little more ground clearance compared to the stock wheels. Let's take a look at the suspension. The car was originally a brushed car, which means the cheapest version. The outdrives, the diff cups and also the differentials are now made of metal. Everything is rebuilt with the original parts from the 18859A brushless model. If you have this version, then almost all the drive parts are already made of metal straight from the factory and you do not need to upgrade it. What I have also installed is a kit of aluminium parts that Haiboxing offers as upgrade parts. But let me take the wheels off to have a better view on this. These are the blue anodized steering knuckles. They look way better than the plastic ones and offer a bit more stiffness and have less play in the bearings. I did not install these steering arms from the kit. The quality of the bearings and bolting is so poor that you would have even more play in the steering than before. In addition, the track would always adjust itself while driving. The kit includes 3 links. One is for the connection to the servo and the other 2 are the tie rods to the steering knuckles. Instead, I used the tie rods from the 1/18 scale Arrma granite chrome. They fit 1:1 on my Haiboxing and are of a much better quality. I'll put a part number in the video description. In addition, the ends of the tie rods are made of plastic, which absorb the energy in the case of a crash and don't bend the whole tie rod. The car originally has some toe out on the front axle, but I wanted to have the straight line ability to be a little bit better. Therefore, I set the toe directly to 0. The wheel hexes are also still the stock ones, but I think I will upgrade them in the future to aluminium ones, because the plastic hexes will wear out after some time. What I also want to talk about are the wheel bearings. I have replaced the inner and outer ones with sealed ones. This protects against dirt and faster wear. And you can see that there are small shims between the bearing and the bearing pin. I used these to compensate for the small amount of play between them. I think on my car it was about 0.3 mm per side. I said that many parts of the Arrma granite chrome would fit. This also applies to the control arms. On my model I replaced the upper ones on the front and rear axles with those from the Arrma. These are of a higher build quality and have bearings with less play than the Haiboxing parts. And they are easily available here in Germany. Here I'm holding the original part in my hand. You can see that the dimensions are exactly the same. The same applies for the control arm on the rear axle. You can change the lower control arms in the same way, but there's one thing you have to consider. The Arrma parts just have one mounting point for the shock absorbers. And that is exactly the inner point of the original part. So there's nothing to be said against using these parts. However, I use the outer mounts so that the car is a little bit firmer and lower. And that's why I continue to use the Haiboxing parts here. The same applies for the front axle. Here you can see which mounting point I use, and these points are not existing on the Arrma control arm. I replaced the servo with this one from Savöx. This is the 0255 MG Plus. a nano-sized digital servo with metal gears. It can be operated with 6 volts. As I didn't have a datasheet for the old servo, I assumed that it could only be operated with 5 volts. A digital servo has a faster response and a constant torque over the entire travel of the servo arm, and also an increased holding power when it's not moving. I have also used a servo saver from GPM Racing. This is actually also for the granite chrome, but fits perfectly for our application. Yeah, except for this small cutout that I had to make in the housing. In general, I would definitely recommend the use of a servo saver. Otherwise, if there is a hard hit on the steering, the gears on the servo can break, even if they are made of metal. Before I show you how the servo works, I'll show you quickly the telemetry data on the remote control. The 8.4 volts is the voltage of the remote control itself. The 7.4 volts is the voltage of the LiPo inside the car. And when I jump to the third menu, I see the 6 volt voltage of the receiver to supply the servo and the lighting. A characteristic of the Savöx servo is that the logic must be reversed so that the steering works in the correct direction. Take a look at channel 1. The steering movement is exactly the opposite to the display. However, this is not a problem and can simply be set to reverse in the remote control. Oh, and if you are wondering about these servo noises, this seems to be normal with Savöx servos. I haven't looked into this problem any further, but maybe one of you guys has an idea or explanation. I will put the car back together and then we can talk about the last 2 details. You've seen a rear spoiler all the time and I haven't said anything about it yet. It comes from a Haiboxing 901-112 scale car. It fits surprisingly well on the small 18859. However, you only use 2 of the 4 available mounting points, but with slightly longer screws the spoiler is firm enough. On the one hand I installed the spoiler for optical reasons, and on the other hand it replaces a wheelie bar. When the car does a wheelie, and it will do that, the spoiler prevents from flipping backwards. It just scrapes over the road, but that's not a big deal. Finally, I would like to talk about the shock absorbers again. I have already described the conversion in my other video. However, I didn't know which shock absorber oil was in the shock absorbers from the factory. Even the support team at Haiboxing couldn't answer this question properly. That's why I ordered different oils and tried out myself. In the end, my setup looks like this. I use a 30 weight oil or 350 CST at the front, which is slightly softer than at the rear axle. There it is a 35 weight or 400 CST and therefore a little stiffer, because otherwise the rear axle would simply be too soft. You could also try a 40 weight oil at the rear, because it has a tendency to bottom out a little faster. However, this is no great effort and can be done quickly. Overall, I'm very satisfied with the suspension. The handling of the car is really great for my driving style. I choose a slightly softer setup as I don't do huge jumps in skate parks with it. The car is just too good for that and I don't want to destroy it. If you are planning to do bigger jumps with it, or you have an overall harder driving style, then you should just use a stiffer setup. One last hint. To make the spoiler fit, I obviously had to make these 2 cutouts in the body shell. It's very easy to do and you can then simply fit it. I hope you enjoyed the video. I think I have shown you all the upgrades and modifications of this car. If you have any further questions, please write them in the comments below. I will try to answer everything. Maybe I can also make another video about this car if there are a lot of questions. But now, let's have some fun.